Hello everyone. Today's lesson is about the index laws, and here we are going to learn about the second index law. This is lesson 2 about the indices. And here we are going to learn about the law of division in indices. So we have, let's say, two power expressions with the same base a and different exponent values m and say n. So one is a to the power m and another is a raised to the power n. And let's say I am dividing these two power expressions. So I can write them as a raised to the power m divided by a raised to the power n, or I can write them in a fraction form. So this would be equals to a raised to the power m take away n. So numerator exponent value minus denominator exponent value. Now we will learn how this formula is generated. So let me give you an idea about that. For example, I have 2 raised to the power of 4, and which means 2 times 2 times 2 times 2. And if we have another one is 2 raised to the power of 2, which is 2 times 2. Let's say I am dividing 2 raised to the power 4 by 2 raised to the power 2, which means I am dividing their expanded form. I can write that way. So these 2's will be cancelled, these 2's will be cancelled. So we will be left with 2 to the power of 1, 2 to the power of 1. So I can write it 2 raised to the power of 2. And if I look at this part and look at this part, I can say that this is equal to 2 raised to the power of 4 minus 2, means if the bases are same and I just subtract the exponent values for the expressions in division, so I would get the same result. You can write it like 4 also if they are only numbers. Let's do some more examples. For example, I have x to the power of a divided by x to the power of b. So this will be equals to x to the power of a minus b. Let's say we have x to the power of a over x. So this will be equals to x to the power of a. You can rewrite it as x to the power of a divided by x to the power of 1. And then you can subtract them, a minus 1. Do not say this is 0. No. If nothing is written, so exponent value here is always 1. So we can write it this way. Let's say you have a question, something like x to the power of 4 over x to the power of n. So this will be equals to x to the power of 4 minus n. Let's take few more examples. X to the power of n, 2n plus 5 over x to the power of minus n plus 2. So how we can apply this index law? This is in the two power expressions are in division. Bases are same, so powers will be subtracted. So the first power, the exponent value is 2n plus 5. And because here we have two terms, so always better to write minus the expression in bracket. Don't write it directly 2n plus 5 minus n plus 2. No, that is a wrong way. Always whenever you see an expression which you have to subtract has more than one term, always write it in bracket with a negative sign in front of the first bracket. So this will be equals to x to the power of 2n plus 5. Then here nothing is written, so it is like a 1. If nothing is written, so it is always 1. So minus 1 times n will be plus n or 1n, and minus 1 times 2 will be minus 2. Now because this is an expression and I can see that there are few like terms also, like 2n and n. These are the like terms and we have to add them. So this will be x to the power of 2n plus n, which is 3n. And then we have the two numbers 5 minus 2, which is equal to plus 3. So this will be the final answer. Do not leave it up to this point. If you get an algebraic expression for the anywhere in the mathematics, or let's say an exponent or anywhere, you always have to give the most simplified answer. Okay. So this was the index law with the division. Now we can discuss about some questions which are based on the two laws, multiplication and division. because multiplication law I have explained in the first lesson, and now because we have learned the division also, so we can use both of these. For example, we have x to the power of a times x to the power of 2 divided by x to the power of 4. So what you can do, we have to simplify this, meaning I have to convert it into a single power expression. So now it is up to you, because we have multiplication and division. You can apply any one of the law like multiplication or division first. I would prefer to solve the multiplication part first. So as per that law, it will be x to the power of a plus 2. You can mention here that you applied this law of multiplication of indices, that it will be a plus b here. And then it is divided by 4. So now it will be, now I can apply the division law. So it will be a plus 2 minus 4. Because here is a single term, so you can write it without bracket. Now it will be, because we can further simplify this expression, so it will be x to the power of a minus 2. So this is the final answer. Okay. Now there will be many other type of questions also possible. For example, I have x to the power of a plus 5 times x to the power of n plus 3 divided by x to the power of 3 times x to the power of n minus 5 plus 4a. So here also you can apply the laws step by step. What I do, I prefer to apply the multiplication law first in numerator and denominator, and then I will apply the index law. So it will be x to the power of a plus 5 plus n plus 3 whole divided by x to the power of 3 plus n minus 5 plus 4a. So I can further simplify these exponent expressions, the expressions in the exponents. So this will be x to the power of a and n, they are not like, so I will just write them as it is. 5 plus 3 is equal to 8 divided by x to the power of 4a plus n and minus 2, because 3 minus 5 is minus 2. And 4a and n you can write in any order, like n plus 4a or 4a plus n, it does not matter. Even you can write this minus 2 also in the beginning. Now we will apply the index law of division. So it will be x to the power of a plus n plus 8. Now because here in the exponent we have more than one term and we are subtracting, so better to write them in the bracket. So this would be equal to x to the power of a plus n plus 8 minus 4a minus n plus 2, because this minus will change all of these terms signs. Now we have like terms here, a and minus 4a. So how we are going to write this whole thing now? A minus 4a is going to be x to the power of negative 3a. You must know the negative numbers rules. Then n minus n would be 0. And then we have 8 plus 2, which is 10. So this would be the final answer, because now these are not the like terms. We cannot simplify them anymore. So this is the final answer. You can write it like x to the power of 10 minus 3a as well. This is up to you. Then index laws we can apply in some questions like an equations also. For example, you have x to the power of n plus 3 over x to the power of 2n, and that is equals to x to the power of 4. Find n. The question would be something like this. So as I see, on one side it is x to the power of 4. On another side it is x to the power of n plus 3 divided by x to the power of 2n. So first thing I should do is I need to convert this left expression into just a single power expression. So I will apply the power rule. So n plus 3, power rule, not power rule, it's basically the division rule. So n plus 3 minus 2n is equals to x to the power of 4, which implies x to the power of 3 minus n is equals to x to the power of 4. Now because the bases are same, and you have an equation and the bases are same, so exponent values would be equal. So I can say 3 take away 4 is equals to n, where n is equals to negative 1. So these all are the examples related to the second division law of indices. And some of the questions I explained were using both multiplication and division law. You can use all of them together. There is no issues. And we did this last question where we had an equation with the power expressions and we have to find out the value of the variable. I hope it is clear to you. Thank you.